We'll start the second part of this lecture with firewalls. Firewall is an important component to host-based security services such as an intrusion detection system. Let's first watch a video and learn about firewall.
When we use the internet to shop, bank, or otherwise use our personally identifying information, we open ourselves up to many risks. Cyber threats like spyware, identity theft, and other attacks can all happen on a machine that isn't well protected. That's where a firewall, one of the most important security features you can have, comes in. A computer connected to the internet is constantly sending and receiving information. This information comes in small units called packets, and a firewall acts as a traffic cop for these packets. It's a layer of protection between your computer and cyberspace. It decides which packets are safe to let in and out, and which should be stopped at the door. There are three types of firewalls. Personal firewalls generally protect only one computer or a small home network. Departmental firewalls, which might protect a small business, protect a limited number of computers in one location. Finally, enterprise firewalls might protect thousands of users in various locations. Firewalls are also available in a number of formats. Many network routers, which connect computers to the internet and transfer data between different networks, have limited firewall capability. In other cases, you can use a firewall appliance, a piece of hardware integrated with firewall software. Some firewalls are software only. This category includes most personal firewalls, but some large enterprise firewalls are also software-based. Finally, a type of network device called the all-in-one tool is getting more popular. Some of these devices act as cable modem, router, network hub, firewall, and wireless base station all at once. Although these devices are cost-effective, often the firewall functions on these devices are limited. When you set up a firewall, you define the criteria for incoming and outgoing traffic. Blocking unwanted incoming traffic is the most common feature of a firewall, but a good one will also screen outgoing traffic from your network to the internet. For example, if you're an employer who wants to block employees from accessing certain websites. Firewalls can screen network traffic based on content and report on what kind of traffic is coming and going on your network. For example, some firewalls can integrate with a virus scanner or email program to screen out malware or suspicious email messages.
A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on the predetermined security rules. Typically, a firewall is inserted between the premises network and the internet to establish a controlled link and to erect an outer security wall or perimeter. The aim of this perimeter is to protect the premises network from the internet-based attacks and to provide a single choke point where security and auditing are imposed. Also, firewalls are deployed internally in the enterprise network to segregate portions of the network. Therefore, a firewall provides an additional layer of defense, insulating internal systems from external networks or other parts of the internet network. There are three design goals for a firewall. First of all traffic from inside to outside and vice versa must pass through the firewall. This is achieved by physically blocking all access to the local network except through the firewall. Second of all, only authorized traffic, as defined by the local security policy, is allowed to pass. Various types of firewalls are used, as they implement various types of security policies. Third of all, the firewall itself is immune to penetration. This implies the use of hardened system with a secured operating system. In general, firewalls use four techniques to control access and enforce the site security policy. The first technique is service control. It determines the type of internet services that can be accessed either inbound or outbound. The second one is direction control. It determines the direction in which particular service requests are initiated and allowed to flow through the firewall. The third one is user control. It controls access to service according to which user is attempting to access the service. The final technique is behavior control. It controls how particular services are used. For example, the firewall can filter email and eliminate spam or enable external access to only a portion of the information on the local web server. Now let's discuss the capabilities that are within the scope of a firewall. A firewall defines a single choke point that keeps unauthorized users, prohibits potentially vulnerable services from entering or leaving the network, and provides protection against various kinds of IP spoofing and routing attacks. The use of a single choke point simplifies the security management because security capabilities are consolidated on a single system. A firewall also provides a location for monitoring security-related events. Audit and alarm are implemented on the firewall system. In addition, a firewall is a convenient platform for several Internet functions that are not security-related, including a network address translator, which maps local address to the Internet address, and a network management function, which audits and logs the Internet usage. Finally, a firewall serves as a platform for implementing virtual private networks. A firewall also has several limitations. It cannot protect against attacks that bypass the firewall. Internal systems can have dial-out capabilities to connect to an Internet service provider. An internal local access network can support a modem pool that provides dial-in capabilities for traveling employees and telecommuters. This can bypass the firewall. Furthermore, a firewall does not fully protect against internal threats, such as disgruntled employees or employees who unwittingly cooperate with the external attackers. Also, an improperly secured wireless local access network can be accessed from outside the organization. An internal firewall that separates portions of an enterprise network does not guard against wireless communications between local systems on different sides of the internal firewall. A firewall acts as a packet filter. It operates as a positive filter, allowing only packets that meet specific criteria, or as a negative filter, rejecting any packet that meets certain criteria. Depends on the type, a firewall can examine one or more protocol headers in each packet, the payload of each packet, or the pattern generated by a sequence of packets. In general, there are four principal types of firewalls. The first type is packet filtering firewall. It applies a set of rules to each incoming and outgoing Internet protocol packet, and then forwards and discards the packet. A simple packet filtering firewall must permit inbound network traffic on all ports of TCP-based traffic to occur. This creates a vulnerability that can be exploited by unauthorized users. A stateful inspection packet firewall tightens up the rules for TCP traffic by creating a directory for outbound TCP connections. Specifically, it reviews the same packet information as a packet filtering firewall, but also records information about the TCP connection. An application-level gateway, also called as an application proxy, acts as a relay of application-level traffic. It filters incoming traffic to certain specifications, which means that only transmitted network application data is filtered. A prime disadvantage of this gateway is the additional processing overhead of each connection. A fourth type of firewall is circuit-level gateway, or circuit-level proxy. It is either a standalone system or a specialized function performed by application-level gateway for certain applications. It monitors TCP connection between packets to determine whether a request session is legitimate. Finally, the next generation firewalls, which are implemented in either software or hardware, are capable of detecting and blocking complicated attacks by enforcing security measures at the protocol portal and application levels. The difference between a standard firewall and the next generation firewall is that the next generation firewall performs more in-depth inspection and in smarter ways. Next generation firewalls also provide additional features such as Active Directory inspection support and secure sockets layer inspection. Next, we're going to introduce security considerations for network management. The principal security objectives related to a network device configuration include ensuring the accurate configuration of network devices and confirming that the configuration does not compromise the security of the network. The SGP recommends organizations to cover several components in their policies and procedures for device configuration. They include security architecture principles, standard security management practices, device configuration, restriction of access to network devices, vulnerability and patch management, change in routing table and setting in network devices, and regular review of network device configuration and setup. For physical network management, organizations need to address three aspects. The first one is telecommunication cables. Telecommunication cables, both within a site and providing external access to a site, need to be physically protected. It includes using a moored conduit, locking inspection and determination points, and avoiding routes through publicly accessible areas. The second aspect is network access points. It is important to store network access points in secure environments and make sure they are subject to physical security policies. The final aspect is network documentation. It is important to clearly document network configuration and its functionality. In addition, the Telecommunication Industry Association standard specifies the minimum requirements for telecommunications infrastructures, and data centers. It describes detailed architectural, security, electrical, mechanical, and telecommunications recommendations. The security aspects of network management for wireless access have two main objectives. The first objective is to ensure that only authorized individuals and computing devices gain wireless access to networks. The second objective is to minimize the risk of wireless transmission being monitored, intercepted, or modified. In his article, Best Practice for Wireless Network Security, Dennis Kennedy provides a useful list of risks associated with wireless access and mitigation techniques. The following list shows such risks and mitigation techniques, and they're listed here on this slide. The principal security objectives with respect to external network connections is to prevent unauthorized external users from gaining access to information systems and networks within the enterprise. The SGP provides a list of suggestions for external network connections. They include restricting external network traffic to only specified parts of the information systems and networks, and define entry points, verifying the sources of external connections, limiting access to devices that meet minimum security configuration requirements, using firewalls to ensure security policies, and using a virtual private network for devices. The security management of firewalls requires a clearly defined firewall policy. The policy should be compatible with the overall security policy and a plan for implementation and operation of the firewalls. The Network Institute of Standard and Technology defines a firewall policy as a description of how an organization's firewalls should handle inbound and outbound network traffic for specific IP addresses. It also addresses ranges, protocols, applications, and content types based on the organization's information security policies. It makes the following recommendations with respect to setting firewall policies. It also offers the following advice for 5 phases of firewall planning and implementation. Remote maintenance refers to the maintenance activities conducted by individuals who are external to an information system security perimeter. Remote maintenance is a convenience to the enterprise, and in some cases, it is a necessity for the organization. The principal security objective in the remote maintenance is to prevent unauthorized access to critical systems and networks through the misuse of remote maintenance facilities. The U.S. Department of Homeland Security has compiled a list of requirements for remote maintenance of industrial control systems, which are applicable to general IT systems as well. Often the focus of enterprise security is protecting stored information and server facilities, as well as client and server communication from the wide variety of threats. It is important to not overlook security related to electronic communications between individual users that may not involve server or database access. Particularly, we will look at 4 types of electronic communications that need to be protected. For both organizations and individuals, email is pervasive and vulnerable to a wide range of security threats. Email security threats are generally classified as authenticity, integrity, confidentiality, and availability-related threats. Authenticity-related threats can result in unauthorized access to an enterprise email system. Integrity-related threats can result in unauthorized modification of email content. Confidentiality-related threats can result in unauthorized disclosure of sensitive information. Finally, availability-related threats can prevent end users from being able to send or receive email. To assist in addressing these threats, the National Institute of Standards and Technology special publication provides recommendations and guidelines for enhancing trust in email. Many organizations provide email accounts for their employees to enable them to send and receive emails within their organization and over the internet. For such employees, it is recommended that an acceptable use policy to be defined and agreed to by the employees. An email acceptable use policy is suggested to include the following components, and they are listed here on this slide. In addition to an acceptable use policy, an organization needs a security policy for email that specifies how email is being handled, transmitted, and stored. The ISO 27000 series Code of Practice for Information Security Controls includes the following considerations for protecting email. There is another type of electronic communications within an organization, instant messaging, IM. Instant messaging is a communication service in which short messages appear in a pop-up screen as soon as they're received. Instant messaging uses a shared software client between or among two or more people using personal computers, smartphones, or other devices. The communication is done over a network, often the internet. It can include voice or video and allow file transfers. Most instant messaging services offer presence information that shows whether a user is online or available to send or receive messages. Enterprise instant messaging services provide real-time message passing within private and public networks. Infotech developed a template for instant messaging acceptable use policy. It includes the rules that comprise the policy, including supported instant messaging solution, acceptable use, confidentiality, file sharing, personal use, compliance, and privacy. Although it introduces various risks to enterprise networks, instant messaging is often poorly supervised. Threats include viruses, spams, malware, and phishing attacks, inappropriate use, and regulatory non-compliance. Therefore, if an organization is going to enable its employees to use instant messaging, a corporate instant messaging secure policy is essential, and it needs to be backed up by user awareness training and an acceptable use policy. There are two basic approaches enabling an enterprise to maintain security over instant messaging. Both approaches limit employees to the use of the enterprise-mandated instant messaging facility. In addition, both approaches further limit the group of employees who can use instant messaging. One of the approaches is to host an enterprise instant message server in-house. This enables the enterprise to enforce its instant messaging policies through traffic analysis and reporting, as well as message keyword searches and message archiving. Another approach is to use cloud service. This means an enterprise does not need to install additional hardware and software. All messages sent to and from the enterprise network are routed through the cloud service, where they are scanned for virus, worms, and malicious sites. The third electronic communication that needs security attention from the enterprise is voice over IP networks. As voice over IP network becomes mainstream, a number of security issues must be understood and addressed, and the following list here on this slide shows the key areas of concern. There's also several specific threats to the use of voice over IP, including spam over internet telephone, eavesdropping, theft of service, man-in-the-middle attack. And a number of security measures can be taken to protect voice over IP traffic, including encryption, VPNs, port administration, etc. And the fourth electronic communication that needs security attention is telephony and conferencing. The security objective with respect to telephony and conferencing is to prevent and detect unauthorized use or misuse of facilities. This is achieved with a combination of physical and logical controls. To help organizations, the SGP recommends a list of requirements that need to be addressed in their policies.